Hey guys! So today looks a little bit different than the past experiments we've been doing in this class. Today I made a presentation on how a nuclear bomb or a nuclear weapon works and the components necessary to achieve reaction required for nuclear fission. This was the prompt for the assignment. Now, obviously, sitting here in my office, as we said, we're not creating a nuclear bomb. We're not creating a nuclear weapon. So I just want to very quickly walk through with you the components necessary for nuclear fission, because I believe nuclear fission is obviously, it is the core of the bomb. It's the core of the weapon. What creates that explosion? Anyways, pick that picture, kind of timely. Going into it, we first have to have an understanding of atomic structure and radioactivity. So on a very basic level, the foundation of understanding the nuclear bomb is understanding the atom. Here are a few bullet points. 1. The atom is made up of 3 subatomic particles: protons, neutrons, and electrons. Here, in the nuclear fission type of thing that we're talking about, the neutrons are going to be the most important part. Specifically, atoms with a different number of neutrons are called isotopes, and isotopes are typically radioactively unstable. And most atomic neutrons are stable, but the few that aren't are often radioactive. So I want to talk a little bit about radioactive decay. I'm not really going to touch on alpha and beta decay, but the specific one I wanted to touch on is spontaneous fission. So when 2 unstable atoms put off radioactivity, it results in 3 different forms of radioactive decay: alpha decay, beta decay, and spontaneous fissions. This is critical to nuclear weapons. A nucleus splits into 2 pieces, ejecting neutrons and putting off an electromagnetic explosion, aka energy. This is called gamma rays. Spontaneous fission is something that is very important to remember about nuclear weapons. And in fact, it is the core. Nuclear fission is the core of what we know about nuclear bombs, nuclear weapons, any form of nuclear threat on our society. So nuclear fission happens in 2 ways. The nucleus of an atom is split into 2 subatomic particles with a neutron, releasing energy. And then also the sun leads up the energy process, bringing 2 smaller atoms together to form 1. Specifically here, we're looking at number 1, when the nucleus of an atom is split into 2 small parts with a neutron, and that keeps on just moving around. Keeps on flowing is what I'm trying to say. That process isn't just a single standalone process. To think about it in terms of this, it's like, say you had a pile of marbles and you flicked one marble into the whole pile. You release a bunch of smaller parts. Well, those smaller parts are then going to experience the same reactions, and they're going to release a bunch of smaller parts. And so what we're looking at is a very quick, spontaneous cycle. So nuclear fuel. In 1940, Bohr and Wheeler discovered that uranium-235 is the fuel necessary for nuclear reactions. Uranium-235 is one of the few elements that can undergo reduced fission. Essentially, instead of waiting for uranium-235 to decay, scientists discovered that if a neutron runs into a nucleus, the nucleus will absorb the neutron, it will become unstable and split. This is a good thing. This is also a really horrible thing, and it has caused mass devastation in our society, in previous societies, as we've seen in history. So obviously, in the hands of the wrong people, this can be very devastating. On top of nuclear fuel, once the nucleus absorbs the neutron, it splits into 2 lighter atoms and ejects several more neutrons. Gamma radiation is emitted from the lighter atoms. So gamma radiation is harmful. It's what comes from the nuclear weapons, as well as probably other forms of radiation, I'm sure. The process continues in a cycle that happens very quickly. The time to capture a neutron and split happens in picoseconds, which is the number you see there on the screen. Very, very, very small. And so, yeah, the picture I put up there kind of demonstrates, the neutron moving in to split the nucleus, splits off into 2 lighter atoms, and then you have other neutrons going to split up those 2 lighter atoms, which then split into other smaller parts. And so you just see this continually moving on and on. Anyways, that's a little bit about the components necessary for nuclear fission. I'm sure there's a ton more, but for the sake of this and for the sake of the fact that we weren't really hands-on with this, I wanted to keep it pretty basic and pretty simple. Anyways, thanks for watching.